Alright, we're going to graph y equal to x squared plus 2. I'm going to substitute negative 2 for x first, so I can get some ordered pairs, so I can plot them. Negative 2 squared is 4, and 4 plus 2 is 6. So our first ordered pair is negative 2 comma 6. Now let's substitute negative 1 for our x value. See what we get. Alright, negative 1 squared is just positive 1. And positive 1 plus 2 is 3. So our next ordered pair is negative 1 comma 3. Alright, now we're going to substitute 0 for x, so y equal to 0 squared plus 2. 0 squared is just 0, and 0 plus 2 is just 2. Alright, our next value is going to be 1. We're going to go 1 squared, and then we're going to add 2 to it. 1 squared is just going to be 1 times 1, which is 1, and 1 plus 2 is 3. And our last value on our table is 2 for x, so we're going to substitute 2 for every time we see an x. 2 squared plus 2. Order of operations says we got to do the 2 squared first, so 2 times 2 is 4, and 4 plus 2 is going to give me 6. So our last ordered pair is going to be 2 comma negative 6. Let's go plot these points on our graph. Negative 2 comma 6 is right there. I like to label my points because I think it looks nice on your graph. Our next point is going to be negative 3 comma, negative 1 comma 3. Our next point is 0 comma 2. Next is 1 comma 3, and the last one is 2 comma 6. Let's connect our points, make our pretty little parabola. Okay, make sure you draw your arrows on the top to show that this parabola continues upward, right? And I'm going to label the equation of this parabola right there next to the graph because I think that looks nice. It shows confidence in your work. I'm going to now make a dashed line to represent the axis of symmetry. And the equation of the axis of symmetry is x equal to 0. And if we look on the sides of the axis of symmetry, we can see that symmetry. All of these points on the left, they look like the mirror image on the right. 0 comma negative 2 is a special point. That's our vertex. And if we were to compare this to our original parent graph, we could see that the vertex from our parent graph actually got shifted up 2 spaces. I'm going to draw our parent graph right below this graph, so that way you can actually see that translation, how this parent graph was shifted upwards 2 units. Okay, I'm going to highlight the vertex on the original parent graph, and I'm going to draw 2 little blue arrows showing how that vertex was shifted up 2 units. Now let's do the same thing for this other point right here. If I look at this point right here, it's shifted up 2 units. And if I look at this blue highlighted point on the parent graph, it actually was shifted up 2 units. Now let's go to the right hand side. Let me highlight this point green. You can see how that point was shifted up 2 units. And this point I'm highlighting blue right now is going to be shifted up 2 units as well. Every single point on our parent graph of y equal to x squared has been shifted up 2 units. Or let me let me call it f of x. F of x is equal to x squared, like the one I showed you how to graph on part 1. And we could have identified that by looking at our original equation here, where it says y is equal to x squared plus 2. That plus 2 after the x squared, it shows us that it's going to actually shift the graph of f of x is equal to x squared up 2 spaces. Alright, that was good. That was a good problem there. Let's do another fun problem. Oh, this looks like a fun problem right here. Now we're going to graph y equal to x squared minus 2. Maybe you should try to guess what's going to happen to this graph. Instead of adding 2 to x squared, we're going to subtract 2. So you might want to try to anticipate how that is going to affect the graph of this parabola. Alright, we're going to start by substituting our values just the way we did last time. I substitute there negative 2 and I got negative 2 comma 2. Now I'm going to substitute negative 1 for x. Negative 1 squared is positive 1, and positive 1 minus 2 is a negative 1. So our next ordered pair is negative 1 comma negative 1. Now let's substitute 0. 0 squared, that's just going to give me a 0, and 0 minus 2 is a negative 2. Now we're ready to substitute the next one. Oh yeah, and that ordered pair is 0 comma negative 2. Let's substitute a 1 now for x, so it's going to be 1 squared minus 2. 1 squared is just 1 times 1, which is 1, and 1 minus 2 is a negative 1. So that ordered pair is 1 comma negative 1. And last we're going to substitute 0. I'm just kidding, I meant a 2 for x. 2 squared, I didn't mean equals, I meant minus, sorry about that. 2 squared is 4, and 4 minus 2 is a 2. So we got 2 comma 2. Let's plot these ordered pairs and see how it changed our original graph of f of x is equal to x squared. What's going to be the difference this time? There's negative 2 comma 2, negative 1 comma negative 1, 0 comma negative 2, and 1 comma negative 1, and last but not least 2 comma 2. Let's connect all of our ordered pairs, make our parabola. Make sure you put your little arrows pointing upward to show that it continues, it does not stop. And if for some reason you miss your points, just make your points a little larger and it looks good. Y is equal to x squared minus 2. There's the graph, and if I compare it to the parent graph, it looks like everything got shifted down 2 spaces. Let me draw my axis of symmetry. My axis of symmetry once again goes right through the vertex, and it's right on top of the y-axis. The equation is x equal to 0, and I made it with that dashed line there. And there's my vertex, 0 comma negative 2, the lowest point on my parabola in this case. I'm going to draw my parent graph, f of x is equal to x squared, so that we can compare how it translated all of the points on f of x is equal to x squared in order to create this new graph, y is equal to x squared minus 2. So my original vertex was at 0 comma 0. Now my vertex is at 0, negative 2. That vertex was shifted downwards 2 spaces. And this point right here I highlighted in green looks like it got shifted down 2 spaces. And this point up here I highlighted in blue, it looks like it got shifted downwards 2 spaces as well. Let's look to the right here. Let's highlight this point in green. Looks like it got shifted down 2 units. And this one I'm going to highlight in blue here, it got shifted down 2 units as well. Every single point on my parent graph, f of x is equal to x squared, was shifted downwards 2 units. We could have identified this by looking at the original equation, y is equal to x squared minus 2. That minus 2 at the end there after the x squared, that is what told us that it was going to be shifting our parent graph down 2 spaces. By learning to identify these little tricks, it can really help us real quick on figuring out what our parabola is supposed to look like. Okay, well, that's it for this video. Thanks. Bye.